Assalamualaikum. So we continue with this example of how do you actually design an isolator when you have the third case, the third type of what we call the rotating unbalance case. So we are looking into washing machine as well, because washing machine also have a problem of rotating unbalance. So what is given here, you have mass of 200 kilograms. So I've listed out in terms of the parameters. Unbalanced. So this is very important. You know what it means by unbalanced. If you cannot remember what it is, you look at the units here. It's kilogram meter. So automatically you know this unbalance is actually your ME, where your E is your eccentric distance. Okay. So that's why 0.02 is actually your ME in your rotating unbalance case. Then you have the isolator. It says here deflects by 5 millimeter under static load. So you automatically know this is static deflection. So in millimeter, change to standard units is 0.005 meter. Then you have the omega of 1200 RPM, already converted to radian per second. So we take a look at what are things that we're going to need to find in terms of things that you need to find. Amplitude of the washing machine. So remember the movement of your machine is an output from this situation. So that's why it's X. And the second one is the force transmitted to the foundation, which is Ft. So let's take a look at the equation. So remember here we have this case. You do not have K, isn't it? For your isolator. So you are given the isolator's static deflection. So automatically know normally the static deflection refers to the stiffness of your isolator. Okay, it's related to that. Since you have your M, you have your static deflection, you can calculate your K. So from there only you can calculate your omega n. So in this case it's slightly different. You calculate your K first, you have your omega n first, then only you put in your transmission ratio. So we have done this part, omega, and we have the transmission ratio. You have your omega, you have your omega n, you get your R. So in this problem, it's a bit straightforward than the previous two example because you already calculate your R. So once you have your R, you can straight calculate your amplitude of your washing machine, which is the first part of the question. So you can get it from the transmission ratio equation. Okay, so we're done with first part. So don't worry if the equation looks a bit weird. It's actually the transmission ratio equation, yeah, this part. The second part is you are asked to calculate the force, transmitted force. So basically once you get your transmission ratio, you can actually calculate the transmitted force transmitted. So in this case, it's 44.7. So it's easy. So this is actually, if you remember your transmission ratio, is actually Ft divided by Me omega square. So you just bring Me omega square to the other side of the equation. Yeah. Okay. So easy peasy. So that's all for this problem. Only to calculate the capital X and also the Ft. So a lot of the problems in this chapter is about designing the isolators, whether to find the K or also we want to find the transmitted force or the transmitted ratio. Okay, I'll see you in the next lecture.